My name is Tebogo Mogaleemang, and I'll be your host today. Today, we'll be having a conversation around accelerating private generative AI workloads with modern infrastructure. And I'll be having a conversation. It's not a presentation, really, with David. He will introduce himself briefly from Mjenzi Cloud. A bit of housekeeping today. We'll encourage everyone who has joined to participate as much as possible. So you can ask questions as we are going on. And towards the end, we will have another set of questions to address any issues that you may have. In the interest of time, we've given colleagues about 5 minutes or so from the hour, and we'll just love to get started. But before then, David, can you hear me, sir?
Yes, I can
David?
hear you. Yeah, I can hear you perfectly.
Great. Yeah. So where you went, you can just start with intros and share with us where you dialing from, because I know it's quite late on your side, is it?
Not too late. I'm David Kinyua. You can call me Kinyua. I'm Kenyan, so African. But I'm currently based in Australia. Um, and I lead Mjenzi Cloud, which is a cloud infrastructure services provider business with a heavy focus and concentration in Africa. So happy to have you guys on, and as we discuss, as Tebogo said, we're not talking over you. We're just discussing, what's generative AI and what are large language models and what they look like, how they could be used. So my focus is server infrastructure, working for enterprises, delivering solutions. So yeah, happy to be here, and yeah, take it away, Tebogo.
Thank you. So, yeah, the aim really for today, just to lay the groundwork, is for us just to think about generative AI. It has grown really popular over since 2022, since the introduction of ChatGPT, and it has a lot of promises. There's a lot of buzz around it, but how do enterprises implement Gen AI for them to be able to benefit around our own specific use cases? And also to share how a lot of it is also heavily tied to infrastructure, building those data pipelines, simplifying how you can access your data and all that and all that. So without further ado, we will just love to get started. And to get started, David, how do you frame generative AI yourself? Like, I mean, it's a lot of things. It seems to be a lot of things to a lot of people. But what's the mental model that you kind of use?
I think of it as just a tool set that will help generate an outcome, and the outcome in this case is something that will be useful. So and conversational. So when you think generative AI, in my simple explanation, it will simply be a way to interrogate um, data and a way to get some results, and a way to get an outcome based on some model that has been trained on have some history or some relevant data. So simply put, I would say it's the idea that you're generating an output, which in this case it's answers. In most cases, it's an answer to a question which should have some enterprise use case. Um, and it's not just about conversation. So you can go a lot further than just conversation, as I'll show you. You can do some routine tasks. So you can automate things that you do, and things that lend themselves to automation. You can do with generative AI, because it's really just about picking out and training a system which can basically get you to do, which can get to perform and do tasks as you refine the system. So that's my simple explanation of how it would work. I don't think I could get any simpler than that.
So you know how I think about it. So for me, I think of generative AI as like having a super smart friend. You feed them with like lots of data, and then you keep asking questions, and then they give you responses back. And sometimes they can generate images for you. They can be an artist if you want. Sometimes, you know, it could be a matter of like them writing something for you. But it's a super smart friend that you are interacting with, but they're smart as much as according to the prompts that you are giving the smart friend. So if you don't give them like really smart prompts, the answer they return may not be of high quality, but the better your prompt, the better the response you get from the smart friend. So that's my kind of mental model. But yeah, and with that, like it's a basis, you know.
I was just listening to something actually, and so yeah, and the person talking was saying Gen AI, as we call it, doesn't give you facts. It gives you approximations and estimations and probabilities. So if you're not really going to get facts, you're going to get a probability. So and the reason that's the case is because generative AI deals with a whole bunch of data sets to train the outcome. So you're not looking to go in there for factual information. You're going in there for a probabilistic answer. So and as I'll show you, you can train the model to give you the most probable solution, the most probable answer, to make use of a particular focus and a specialization. What's this here?
Probably probabilistic or not, but it's quite popular, is it? I mean, since the advent of ChatGPT, I really couldn't believe the initial buzz when ChatGPT was introduced. I mean, just for comparison purposes, I mean, it took about 2 months 2 months for ChatGPT to reach 100 million users worldwide. I mean, I find that a really, really mind blowing figure. And on the slides, I think everyone can see the comparison with like some of our popular apps there. So, what do you think is what was driving this uptake in a lot of ways? Was it a matter of people exploring, curious, trying to learn what they could do? How can we explain this?
I think some of it is definitely the curiosity, but it's the novel nature that ChatGPT was delivered, and I think it brought to fruition, a whole bunch of work that these guys, have invested in, and so it's something new for people to experience, and so that gives it a really big buzz initially because, it's we hadn't seen, Gen AI in that scale before they launched it. So it's definitely got to be fascinating to see that, you can freeze, internet and gather, reasonable insights and be able to actually get conversational output. So you're thinking you're gonna get something that resembles someone's conversation. So it's very relatable and it's very easy to access. And so the uptake was quite surprising. It was really hot. So when it came out, it's still hot to some extent.
Yeah. And what we have seen is it quickly moved beyond just text to include videos, to include images. You could give them documents. It could summarize that for you. And that brought like a bit of some question to me to wonder, all right, what are people, since its launch, what are people now using Gen AI for? And in here, I think we have listed a couple of industries, but I'd love to tease your favorite kind of use cases that you have found yourself.
I think the chatbots have got to be by far probably the most useful. And I think chatbots moved from just being simple chatbots to being more your virtual assistants. So giving a little bit more than just, conversation. So you can get, inquiry, you can get customer inquiries happening through them. And no doubt, almost everybody sort of wants to understand, how they're done and wants to implement them. And I think they have played a big part in getting traction on this happening, and I think it's a good thing. And the whole idea for a business, it's to get their data that they're sitting on, accessible in really accessible ways, and easy to use format. So you're talking language. So if it's a real estate company, like we're working with a real estate company at the moment, and they just have a bunch of properties listed, and all the chat function is going to be helping them do is get customers to interrogate that data, as opposed to going on the website and looking for a property. So you can search and ask, hey, can you give me a property in this area? Can you give me a property that has access to schooling? Can you give me a property within X amount of distance from X amount of place? So that interaction is really, really useful, and it saves a lot of time for both the users and also the company. So I think that for me is a really game changer. And obviously, we could have of so many uses around that.
Yeah, I've come to conclude that the use cases are endless. I mean, across all the industries, there are different use cases. Some of them specific to just supporting a service at a general level. Some of them would be very specific to the particular industry itself. And again, companies have their own knowledge base. So the possibilities are endless around just what organizations can be able to build, and just the type of applications that they can build from their own knowledge base, and being able to support customers and all that. I really love the applications around healthcare, especially with the discovery of new medicines, where as human beings, we now have these huge data sets that we can't make sense of. And then we trust this smart assistant to analyze and advise us towards creating things that we couldn't identify the possibilities before. And then we come back after fact to try to understand why it's suggesting and generating those as solutions. I really find that mind blowing. But yeah, thanks for sharing those, David. So I think since we've built up the excitement, all these applications really came from large language models. I mean, these are AI models that were trained from lots of data, public data, really. But is it? They're not enough, is it, for organizations to use as is? So they do have limitations, and I want you to go through your favorite kind of example. I think yesterday we were having a chat and you mentioned a hallucination around something that you did. So could you just take us through some of like the limitations that we have really listed here?
Yeah, and I think it marries to the point that I was making earlier, that you have to remember that these models are large language models, and that means that they're ideally supposed to be just triangulating the information. So trying to get as much information triangulated, if that's the correct word in this instance. They're trying to get you as close as you can to your query. So in usual fashion, you would expect that you're training a model against human generated input. So in the case of OpenAI, which is the company behind ChatGPT, they basically looked at publicly available information on the internet. And we all know that that's got to have some biases of its own. And so when you're talking about things like hallucination, they will happen because the challenge with getting an answer is in the way you ask it. So if you ask a question on the model, you will get an approximation of, the highest probability. So hallucination will happen in the case where the information is either not, hasn't been asked before, so the information is already available to be provided, or in this case, it's approximating to something that's actually not correct. So it could happen. So I once gave a question, against a smaller data set, and I was asking for a particular name of a server, and I was looking for information about a particular thing. But when I was asking the question, I asked the question and added some junk stuff, beside the word, and the answer was basically assuming that I was asking about the correct term. So it works both ways. So you can ask about something that's wrong and you get the right answer. It's not always that you ask the right thing and you get the wrong answer, which is what everybody is assuming. But hallucination can happen both ways as well. So it's the idea that these models are not supposed to be factual, but they're supposed to get as close as possible to the training that's happened against the model. So and there's a lot of computing power that, as we say, that goes into training the models to get the right result. So it's bound to happen.
Yeah. So I tend to think of hallucinations as you ask me a questions, I don't have a clue, but I still give you an answer.
Yeah.
So
Yeah.
if I was that smart friend of yours, you could at this point be asking a question, and instead of saying I don't know, I make things up. And because this is something that we think is smart, sometimes we would just accept that on face value. But then again, David, is the limitation of using only publicly available data. For example, with OpenAI model, the GPT model from OpenAI. So if you are using publicly available data is always growing, is it? So that means you won't have context beyond the data growth at the end of your training. And then also again, these large language models need lots of data, which takes time to train, which means to train this model, you take a lot of time. Can take months. And again, to train this, you need a lot of compute power as well. So the limitations come from there if one wants to train their own thing, that you need lots of resources, compute-wise, storage-wise for your data. Then you need lots of data, which then would then bump up like your price for training the model significantly if you want specific context around your own knowledge base or data. And that kind of now, David, especially with the limitation around that comes with these large language models being trained around public data. All organizations have their own knowledge base. I think people would love to have the same convenience of having a smart friend, but a smart friend who specializes in your own kind of context and knowledge base, is it? So what are some of like the issues that we have seen pushing organizations to think about building their own private generative AI solutions? I think we have mentioned some of them like cost and performance, but I'd love you to maybe emphasize more around data privacy and having domain specificity.
Yes. So the whole reason that you would want to adopt a more private approach to generative AI is definitely around the data security and privacy. So there's a whole discussion around the fact that these public models, they're using publicly available information. But if you think about the way that a company typically would operate, if you're looking for company-specific application of the AI, you would want to train the model against company-specific data. And that's exactly what we're talking about here. We're talking about the need to adapt the AI, not so much adapt, but basically train the AI and to localize it to your use case, to your organization, to your vertical, to your sector. So if you're talking about the financial sector, if you're talking about insurance company, you would want to maintain, obviously, your data privacy, because there are rules governing how you should, sequester and secure data. That's critical, and obviously that's very true for financial sector use cases. You don't want your customer information, especially when it's identifiable or not, to go outside of your entity, because that's definitely not desirable. So you would essentially want to avoid, one, public cloud, but you would also want to avoid exposing your data to the internet, to the external world. So what then would you would require is to build and to train your own private models and to have some specificity. So and the way that the industry has responded is, there's ability to create domain-specific AI, to train the general models that are available, because you still need to sort of have a pre-trained model, and then you need to localize the model, and the work, I think, will definitely show you how that's done. You maintain some specificity because you want to be sure that you're dealing with your sector and you're getting the outcome that you want. So as opposed to ChatGPT, so ChatGPT is what we call a general purpose large language model, but you don't really want a general purpose large language model when you're a bank. You want a bank specific model for maybe helping you with prediction perhaps, or helping you with analyzing fraud. And so you would want to maintain data and application security, and also you'd want to have some local performance that's a little bit better than having to get something from the internet or from the cloud. And so that's what we're talking about when we say you need to think about private AI models.
Yeah. So the main issue is context. You want to get context around what you care about in your knowledge base. Publicly available LLMs, fortunately, are general. So I once again bringing the analogy of a smart friend. You don't want a friend who always has answers that are never specific to what you care about, but they sound reasonable, because sometimes this can sound convincing, but it's literally just garbage in a lot of ways. But I want us then, David, again to share what's the challenge. So if it's costly to train your open AI models, your Llama models, your Gemini models by Google, your bots and all that, they're quite expensive to train. What does then mean? So trying to train your own model from the beginning would be impractical or would be costly. If you have money to spend, yes, you may, but so companies cannot afford to really train their own models. So, and I think I'm trying to queue up what's coming next. So now we want to so organizations want to have their own kind of customized models, fine-tuned to their own kind of context and data. So there are different approaches that they can take. So I know I decided to split the two methods yesterday, David, after our discussion. So we'll start with something that I would consider to be more kind of data centric. So for everyone's benefit, I'll try to write on the slide if I can, but with the vanilla models are quite straightforward. Someone maybe would ask a question, and then there isn't the middle part here that is in red. It would ask a question, it will go to it'll be converted somehow into a representation that the model understands. Then it goes to the LLM model, and then the response is what is then given to the user. So that's the generic kind of approach. But here, we now want to incorporate organizational data. So here, what you see as original content or new content, think of that as organizational data. So with regs, really, well, what is it that we are enhancing here, David? So we and maybe to explain to people, reg itself, that it's retrieval augmented generation. So I think the name itself is a giveaway. So we're augmenting the retrieval part. So can you just quickly just walk us over this one, David?
Yeah, it's
How we managed to bring organizational context to augment the responses of the model.
So without becoming too technical around it, the simple concept is that we want to be able to have some dynamic approach going with your data, so your organizational data. So what you would need to do is you have a foundational model, as you can see there. There's a foundation model. You would then need to basically weight that and present your custom your customer documents, your articles, your live documents, to be able to then allow the model to do its magic. So in simple terms, all we're doing here is we are fine-tuning the model using your specific company information to basically improve its performance. Because remember, the general big large model is not very specific. So the way that we do it on a RAG, or on a retrieval augmented generation model, is to basically boost that performance by altering some of the weights that are in that model. So there's two steps, as Tebogo said. There's retrieval. So when you present a query, the RAG retrieves the relevant information from a knowledge base, which can be your documents, your links, your files, sometimes even voice, and then there's generation, where you're using the LLM to generate the response against the query to provide the context. So I mean, the advantage is it's efficient, it's flexible. You can use the large models and inject into it your local information. And it's a little bit different to the way that you would do it on the next one, which is the one. So ideally, we would mix the two. But you're trying to get efficiency, you're trying to reduce the bias from the model. So if I can say that, because ultimately, whatever is in the general, big data set is going to be quite general. And I think that's a simple explanation of it. So you want to get a good response, and the way to get a good response is to allow the model to be more specific by feeding in more specific company information.
Yeah. So
Yep.
yeah, and like you said, the main idea here, because this is of course oversimplified, is that you have your own private data that is always growing. You have an LLM that was trained with data that maybe stopped at a certain point in time. So you want to give the model the ability to give you reasonable answers relative to your own information base. So instead of sending the original response directly to the LLM, so you have your data, it's represented in a way that would be understandable to the model. So you go to your knowledge base, attach what seems relevant, and then send it to the LLM, and then that's when you get like a response. So the main idea here is that we are not touching the model. We're not touching the model. It's already a pre-trained model, so you're not going to spend any money on training. But all you are doing is feeding the models a bit of your context from your own kind of data. And then from then on, using your whatever is relevant internally, given the response is attached to the LLM and given to the LLM, and then you get like a better response there as well. And or no, I think I'm missing the next one. Okay, this was supposed to be the next one. I'll go back to the other one. So this, I'd love to contrast that, David, with this idea here, because this one is not data centric. Apologies there. It's more model centric, because here we're going to we're going to do some clever things to the model. We're not going to update all the parameters of the model. For example, modern LLMs now have as many as like billion parameters. So these parameters, think of them as knobs that you have to tune for the model to perform better. And you have like a billion of them. So instead of updating a billion of them, with the second method that is more model oriented, what tends to happen is it's a mathematical operation. It's quite clever in that you're figuring out a way of updating the model parameters, understanding what to tune without tuning everything. And you're doing that in clever ways of, all right, what are the minimal things that I may have to tune to get like high performance? So for some of you maybe who have done courses like linear algebra, we will have like a matrix, and then in this matrix would look for the smallest representation of the matrix without losing too much information. And then maybe to bring context, just so that we at a high level, you can think of music. Music files, you can have WAV files, you can have different types of files, and then you have MP3 files. So an MP3 file is a compressed version of the original file. But when you are listening to the music, you can't hear the difference. But what has been done there is that there's been a clever operation to ensure that even though we are reducing the size of what we have to change, but in the bigger scope of things, we're not changing things that much, but we still are able to pick that this is still the same song, it's of the same quality, but the representation there is small. So the same idea, it's also applied here with what we call LoRa, low rank adaptation. So the same model, same size. We don't change it like the previously, but then in order to adapt it to your specific context, we just change the weight. We don't change all this, the all of them. Like for example, 175 billion for I think GPT-3, but we change only a few of them. So you can see here that this idea at a high level really allows us to reduce what we have to tune. The updates that we have to do from about 175 billion to about 4.7 million, which also reduces again the memory footprint of your model now. So you now need a smaller more like a smaller model to get the same benefits. And David, what I want you to bring here is that sometimes these perform better than updating the entire model, is it?
And they should, because you are basically fine tuning. That's the whole concept. So, and the reason to fine tune is to become better. So the bigger model is very specific. So what you're doing is you're applying some magic, and I think your mathematics came out in Tebogo. I think you're very much a math man still. So ideally, you're supposed to do a lot of math to make it better. So that's simply what we're talking about. So you're using weights and adapting the bigger model to get better based on what you want to achieve in terms of focus. So I've done a few use cases against, a simple generation of an automation use case, and I'll show you how that sort of achieves the outcome, which is very specific. So we asking the model to generate a quote, and so we just trained the system on a simple thing. So that's pretty much all I have to say, really. You're trying to get better, so you get better by training the model.
Yeah, so I want our listeners to differentiate the two approaches. That one is data centric. Unfortunately,
Yep.
this one is not data centric; it's model centric. So here we're touching the model and reducing the number of knobs now that we need to chew to play with to get the model to perform better. I really find this fascinating. If it was a technical webinar, we'll dive deeper, but David would show like a demo from an architecture that is leveraging LoRa. I think there was there is a question on Teams. Someone asked whether it's cheaper to train your own model than to let me see that. So I think it's Mililani. Is it cheaper to build your own private model as opposed to using general models? And I think the answer, if from what we have shared so far, is no. It would be expensive to train your own model, and maybe just looking at this because the number of weights these models are they're on specialized infrastructure that is quite expensive, GPUs. So if you are going to change everything, train your own, you'll need a lot of GPUs, and hence you would incur a lot of costs. So there's fine tuning methods, the two of them. You don't retrain, so then you don't incur a lot of costs. But all you are doing is fine tuning. So the effort required to fine tune is less costlier than trying to train everything. And sometimes because they yield better performance there, and then in some cases it makes sense not to put the minimal amount of effort to even outperform something that you could maybe try to train it all from the beginning. So think of fine tuning as a shortcut to get better. So no, it's not cheaper to train your own. So David, this is what you are. So now we thinking. I think I need to go back to here because the other slide was out of position. So organizations have are doing something interesting. Is it? It's not just the model, the data part, but it's also the infrastructure part. So organizations are getting converged infrastructure, specialized infrastructure for AI. And what we have seen, I'm just going to mention two companies, NetApp and Hitachi. And the approach is to give you a single box that is the storage. So your data is sitting close to your compute, so you don't have to wait a longer time. It makes the training faster if the data and the compute are adjacent. And then you have the compute sitting on the same thing. I think most of them, everyone is using NVIDIA GPUs from what I've seen as a pattern. But then on top of the hardware, they also give you software that allows you to interface with like tools that allow you to quickly build things like it can be avatars, it could be like a chatbots, it could be sometimes, and sometimes these are multimodal. So from your data, you have stored on the same thing, your compute, same box, and then you also get software on top that allows you to build that. So, and these are AI centric data. This is AI centric data center infrastructure. David, is there something that you found that is also interesting around this approach?
No,
And how does it allow people to privatize the model, if I may cue you up on that one?
Yeah, it's the ability to buy and localize your hardware as opposed to using hardware in the public cloud. So you can get fully built and customized solutions that allow you to do these things. So that's the benefit of having it. You obviously have to have the data center facility. You have to have somewhere to house this, but it just allows you to have access to these things, to the infrastructure close to you. For sure.
Yeah. So in terms of private, you get a box, you keep it local, and then your data is not seen by the outside world. So you can then enjoy the same benefits that we mentioned there, but from your own infrastructure. And the other approach is that your data is local, but then you connect it to maybe compute resources on the cloud. So maybe you may not afford to have GPUs or the specialized infrastructure. So on the cloud, different service providers, not just the ones I've listed here, provide you an ability to connect data on-prem to the compute infrastructure. Then you are then able to build applications from your own data that only your users can connect to. So there is a certain level of privacy there, but it's not fully private, is it?
No, it's not. So, and typically when you're looking at public cloud, you're utilizing somebody else's servers. In this instance, I'll be showing you some private LLM generative AI models, which we have built and trained on local data, as opposed to if you want to use something from the public cloud, it still belongs to the public cloud company. So there's that distinction. You can have your private, setup, but it's still private in a public cloud setup where you're sharing the resource. Yeah.
Yeah. So the other thing maybe that I forgot to mention here, David, is with the likes of NetApp, you also get, so these ones remove the need to build your own data pipelines, the ability to move data from your storage to your compute. It's out of the box. And that is sometimes where organizations spend a lot of time. And then again, the other added advantage here is you get data management, robust data management out of the box as well. Thought maybe I should emphasize that because I wanted to just highlight how even on the cloud, the focus is in simplifying the workflow itself as well. From how you ingest the data, they simplify how you can build a pipeline. So you just bring your data and like magic, you get data curation, the pipelining around connecting to the compute, it's sorted for you. You can select the right model if you wish to, and you can get accelerated inference. So and sometimes they even give you the ability to make sure that your model doesn't bring new kind of thinking or doesn't go overboard with creating new context with guardrails and all that. So this sort of model can work whether your information is on the cloud or is on-prem. But the main thing is the pipelining, the plumbing is done for you. And that's maybe the key takeaway here. And I think we've covered this. So David, if you're an SME or a startup, you may not afford the phase two solution, which is why we are having this conversation around your infrastructure. I think you can explain this as we move along because I'm a bit cautious of time so that we can leave enough time for the demo and some questions there as well. So you may just briefly yeah.
So the idea is, I'm a cloud infrastructure provider, and Spectrum Analytics, is really they're the data gurus. So if an enterprise would like to have, their own private, LLM or Gen AI model built, the building blocks are quite simple. The infrastructure, I can see the infrastructure is built in a funny way, infrastructure. So infrastructure would have to be coupled with the software, and the software bits are the ones that we were talking about, doing the tuning and the ingesting of the data, and then the output. I'll show you in a second how that looks like. But the idea is, we have access to some pretty amazing open infrastructure, which can help reduce that cost of owning and running the models, and it can be run in a few different ways. Actually, in fact, two ways. So an enterprise can choose to have, the whole entire infrastructure and the software stack built and run by themselves in their own data center or in a co-located data center, or they could choose to consume it and consume it from places like Spectrum or myself, we can provide that as a service as well, meaning you do still have a little bit of flexibility, but you're using infrastructure that's mine to run your use cases. So those are the two ways that the building blocks that we are seeing happening, and we could help you manage that LLM and Gen AI model tuning process to make sure that you're getting something usable for yourself, for your use case. I'll show you about 4 or 5 different use cases if we have a bit of time now, but that's the whole idea. Yeah.
Yeah, and just to emphasize, for the purposes of fine tuning, you are leveraging a low rank adaptation approach, the model centric approach there. So, yeah, just wanted to bring that up so that we can connect the two ideas. Yeah.
Yeah. So we're using actually both. So
I think
in some cases, LoRa is not sufficient, and we have to use the RAG model. But yeah, that's basically what we have to do. Yeah.
Yeah, so yeah, it's important to show that the two methods, it doesn't mean it's either or. So you can combine the benefits, because each method has its own advantages and disadvantages, and you can combine the two of them to even get better. I think you have touched on this, David, that between us, we can be able to help organizations acquire the hardware, and also we can also offer them an ability to bring that data to the infrastructure and just use APIs to connect and train the models and then build applications on top. So to the demo say, and then I'll perhaps restrict you to just 3 so that we can take as many questions as possible.
Yeah, that's fine. I'll share my screen and
okay, let me stop sharing.
Show you. I'll remove my video because so my face can come out of my screen, and I have enough resources to show you. So I'll start from the top. You've only given me 3 takes. So this is how a Gen AI implementation could look like for yourself. So you could have it localized to do, to look various ways. So this is just an attempt at us doing it. This is a lab environment. So you made it look like this. So ideally, you can have whatever vertical you'd like. In this case, we've got some business assistant running. We have a bit of a dashboard looking at the resources for the GPUs. For the test purposes, we're using 4 NVIDIA GPUs from our good friends at NVIDIA. And the reason for that is you have to cluster these GPUs, and obviously GPUs are what's driving a lot of this innovation. So the GPUs are the ones that are doing the tuning. So this model basically is running on premise in a server, just downstairs. And what it's doing is basically, can you see the screen yet?
Yeah, can see the knobs moving there.
You can see it's basically a video because I don't think I have enough time to show through each of them. But ideally, what you can see here is, this has been set up to do a few different tasks. So each of these tasks is a vertical. Each of these tasks is basically a fine-tuned model. So we've done a few of them. I can't show you everything, but I'll be able to show you the SAP one, an automation one, and maybe a penetration testing one. So what were you expecting to see is how to run them. So ideally, you would expect to give some prompts as you would. So it's a little bit different to a ChatGPT model, because a ChatGPT model only exposes the prompt text box. So in this instance, you have access to seeing the parameters, to seeing the model itself, to looking at the training of it. And so that's a little bit of the UI of it. So without too much, I'll show you how a config model would look like. So the purpose of this is to grab, so in this instance, a customer is asking for information for a server and they want a quote. So we requested, someone has sent an email saying, I need a quote with this many resources for a server. And if you're in the business of server or manufacturing something, you would simply get quotes all the time through email. So this model has been set up to pick up emails and generate the quotes. So it's running the model, it's going through the website and generating the quotes automatically. And it will basically grab the resources. As you can see, it's going to generate the quote automatically. It's going to then send the quote to the email automatically as well, and you will see that. And that's all been done and trained on the data. So the training has happened on just the website. The next idea is to take that opportunity and put it onto a CRM, because a CRM is a pretty useful use case for any company. So you would take the same quote that has come in on email and has been sent, and you would trigger another process automatically from the AI saying, hey, you've got this this query. Can you please enter this information onto my CRM? In this case, we've tested with Switch CRM, which is a pretty low-level CRM, and it'll basically get a suitable name for this opportunity, and it'll enter it. So it's basically doing its magic, opportunity created, and you can see that the opportunity is live here as a proposal from this company doing that. You can do the last one, which I'll show you. Obviously, no, sorry, the second last one. I'll squeeze in one more. So SAP is a pretty big CRM. So SAP is a pretty big CRM. So what we've done is we've automated a few processes for CRMs. So if you're thinking, I've just recently done a big SAP project, and we were doing a whole bunch of invoice exception checking, and we were using some other scripts. So you can simply use AI to pick up these things and generate whatever you'd like to generate. So this one is simply creating a user. So you can see here, there is no new user. So we'll go to the model, we'll ask it to generate a new user with a password given. So create this new user with the password, and simply it's going to go and do it. And so if we go back here, that user has been created. The last one is an interesting use case where we've done some pen testing. This is good for IT professionals that are in the process of making sure that their networks are safe. So penetration testing is something that cybersecurity experts do all the time. So they are making sure that the networks are safe. So what you would run is a pen test request, and the AI is trained on a whole bunch of rules to check against your infrastructure in the network. So it'll go on and it'll take a few minutes. Actually, this one takes 4 minutes to run, and it'll generate a report telling you what ports are open, what vulnerabilities actually exist. This probably would have taken somebody, an hour or so. And so that's just a very simple use case. You can run another request to see if there's weak passwords, and this one we ran and we generated about 10 million tries on people's user accounts. And surprisingly, there's some people in organizations that use simple passwords. So this is good for the admins. So that's a very quick rundown of how a pre-trained, private local LLM in generative AI, that's a bit of a mouthful, would look like, and how we would actually deliver use cases. So, and it can be defined and delivered against whatever workload is required. I'm currently working on 2 specific examples for the insurance industry, where they're wanting to get decision support. Another one for the real estate agency, where they're wanting to get automation happening for queries. And so we're just doing a bit of the training. It takes a few weeks to train against customer data, against org data, and then deliver the model on the infrastructure. So I think I've done you, and I've done just as you wanted in 3 minutes. I think we can have 1 or 2 questions.
Yeah. So for anyone attending, remember you can just post your question on the chat, and we'll pick them along as we move. So that's quite fascinating, David. And I think for me the key here, the key takeaway here is that um, LLMs have the limitations. They're expensive to train. So if organizations were to try to train them on their own, they'll need a lot of resources. But not all is lost. Nonetheless, there are some techniques like we have shown with Reg, with Laura, or a combination of the two that can allow organizations to enjoy the same benefits that we've seen from these large language models, but specific to their own context. And I really love the pen test use case there, David. I think for me, it's the ability to support customers, the ability to automate repetitive tasks. So anything really where, one ends up maybe just repeating things that, are always cropping all the time, lends itself towards AI. Anything where you may also want to do something clever with the interaction before maybe giving the user some feedback. I mean, seeing you with the CRM for something like SAP, man, that's pretty amazing. And I would have expected you to share that around some of your favorite use cases earlier on there, David.
You gotta leave the best for surprises. We've also got a really cool one where we're doing a construction uh, assurance where we're just running an architecture design against the model to see against a continuous process of taking pictures of the site, a building site, to actually tell the engineer that, hey, there's a bit of variation happening. Someone is not doing their job, so you can go and do a bit of whipping. So which is a really fantastic, interesting use case. Somebody asked a question here. So when you implement a model for a client, do you do a system analysis on their current systems for integrations? Yes, you have to. So, but fortunately, AI is quite smart. So as you can see for SAP, or you can think of the automation tasks that I've shown you, some of the automation stuff, you can think of them as somebody's joining as we're finishing. Sorry. So you can think of the automation tasks as RPA in the olden days, where you used to have robotic process automation. So think of that automation process on AI now as RPA on steroids, basically. But you're right. So we have to integrate against ongoing systems. But integration is really easy with AI because in the case that I've shown you, we trained the AI on just website information. So we give it an HTML link, and it was able to capture all the data within the link without needing an API. So integration is pretty simple in that way. So you can feed into the system text file, HTML, raw files, video, audio. You can do a whole bunch of things. So again, we have a test lab. If you would like to test some of these things, feel free to reach out to Tebogo or myself, and we'll be happy to test something for yourselves. But yeah, so I think that answers the question, and I think you did answer the question about the cost. So the cost is greatly reduced by the fact that we are fine tuning and training against a smaller subset. So it's a company information. So the model I showed you that was doing the quote process, it's only 32 gigs heavy. So 32 gigs is tiny in terms of video memory. It's definitely happening across 4 GPUs, but on the scale of things, it's not terabytes. It's not terabytes. So 32 gigs of memory on such a useful model is really mind-boggling, and it allows you to save a lot of costs on the setup. So you would probably need 1 or 2 servers clustered. Yeah. I don't think we have any more questions, but yep.
Yeah. So thank you very much, David, and thanks everyone for dialing in today. I hope my discussion with David was useful to you, and if you'd love to get in touch with us, we will follow up after the webinar. So if you have any follow-up questions, please shoot them through. We'll manage to respond. And if you are thinking about experimentation and use cases, I'll speak to David so that, for those who just want to play a bit and experiment, we can see what to arrange for you so that you can start playing with these sort of things. I just want to say that, these ideas seem complex, but are actually very simple once you get to the doing part. So don't maybe think you need to acquire a lot of knowledge to get started. Let's get in touch. We'll follow up. The team will send emails, and then if you're interested, please respond back, and then we'll get back in touch with you. Thank you, David. I know it's now almost late now. It's been a pleasure, my friend, as usual. And I look forward to our collaborations and then bringing more of these going forward. Thank you, sir.
Thank you so
And
much.
bye-bye,
And yeah,
everyone.
I'll be seeing you next month, definitely. Yep.
Cheers, man. See you then.
Cheers. Yep.
Bye.
Thanks all. Appreciate it.